hydroxide, right? Acidic oxides, we have basic, right? So sodium sulfate would be a normal salt. So all the hydrogens are replaced by a metal. Could have been the ammonium ion as well. Alright? If we react this in 1-to-1 mole ratio, you're actually going to get sodium hydrogen sulfate. Okay, so this will be an acidic salt. Another example of acidic salt, for example, if we had sodium hydroxide, okay, H3PO4, so this is phosphoric acid. You can see that we could have sodium dihydrogen phosphate. We could also have disodium hydrogen phosphate. Alright, just to complicate stuff.
So
both these are acidic salts, alright? The salts that we are used are normal salts, right? Alright, so some salt, whenever they actually crystallize, because you know, like sodium chloride table salt, those are what we call crystals. So they will leave from the solution to form crystal looking stuff, like table salt. They say look like some crystals. That's how salt will precipitate out of solution to form crystal looking stuff. Some salt in their crystal lattice, they actually have a certain amount of water to help arrange the structure properly. Right? Those are called water of crystallization. So they are not really part of the ionic molecule, but they are part of the structure that is required to make the lattice. Alright? But in truth and in fact, sometimes they are actually, in terms of the transition metals, sometimes they're actually what we call some ligands of the metal, but you don't really need to know this at this level. So that is why I just want to say that the water is required to form the crystal structure, right? But if we should heat the crystal structure, then the water can actually leave the ionic compound dry behind, right? So this is a fixed proportion of water molecules held within their crystal lattice. Right, so some salt form water crystallization. Right? Fixed proportion of water molecules held within their crystal lattice. Let's see. Example that they use in this book is copper sulfate. So remember that this is what this is a dot 5H2SO4. So this solid here is going for the entire thing here, not just the water. So this is not really ice, this is room temperature crystal solid. Alright? So blue crystal hydrated, right? Right? And if you should heat this, actually would form copper sulfate solid plus 5 water gas. This is white powder. Alright? So when we are preparing a salt, we have to take into consideration the solubility of the salt being prepared, so whether the salt is soluble or insoluble. Alright? We also have to take into consideration the solubility of the reactants used. So whether the acid or whether the base is soluble or insoluble. Alright? Good. And also whether the salt being prepared would require like a water of crystallization or not. Alright? Because say for example, just randomly you want to prepare the copper sulfate 5 water, the example that we used previously. There is no way on earth we could use a direct reaction between like say the metal and an anion. Right? Because that would require heat and we could not get the water of crystallization. So that would simply mean that it would have to be prepared in solution and leave to crystallize out of solution. Alright? So these are 3 rules. So I write them here, so please ensure that you have these in your flow diagram. First question is the salt soluble or insoluble? If it's insoluble, use ionic precipitation. It's soluble. You have to ask another question. Is it potassium, sodium, or ammonium salt? So if it is a sodium, potassium, or ammonium salt, we use titration, alright? So it's 2 methods we have seen thus far, alright? So we see one method is ionic precipitation, the second method is titration. Following? So 2 methods we have looked at so far, right? And if it's no, we have to ask another question, right? Is the salt and anhydrous chloride.
Yeah.
Yes. So this is the first method, the second method, third method, right? And if no, metal are insoluble, base are insoluble, carbonate with acid. Alright, I know that you can't see around here, right? So the fourth, so basically four methods used to prepare salt. 1, ionic precipitation. 2, titration. 3, direct combination, which we use for the anhydrous chloride. And 4, reaction with the metal plus the acid, insoluble base plus the acid, insoluble carbonate plus the acid. Clear?